Previously we just studied how to represent any given decimal number using binary coded decimal technique. Okay, we took some examples and we converted each of the given decimal numbers into the binary coded technique, and we represent it in binary coded decimal format. So in this part we will do the opposite. We will be given a BCD code and we have to convert it into its equivalent decimal form. Okay, so let us take an example. Let's say we have been given a BCD code as 1 0 0 0 0 1 1 0. Okay, so the first step which is involved in conversion of a BCD code into decimal is that to split the given decimal number, not to split actually, to make 4-bit groupings of the BCD code. Okay, so we have to make 4-bit bunches or 4-bit groupings of the given BCD code, and it is also similar to the decimal to hexadecimal conversion. It is similar to decimal to hexadecimal conversion. Binary to hexadecimal conversion. Okay, there also we did the same thing, not decimal to hexadecimal, binary to hexadecimal conversion. It is similar, the technique is similar to that, binary to hexadecimal conversion technique. So we have to make 4-bit groupings. What we have to do, we have to start from the least significant bit and we have to make 4-bit groupings. This is one 4-bit grouping, this is one 4-bit grouping, and we have to write them separately. 0 1 1 0, and this is 1 0 0 0. Okay, now we have to convert each of these 4-bit binary numbers into their equivalent decimal form. This is the binary representation of the decimal number 8. This is the binary representation of the decimal number 6. So this BCD code, if we convert it into decimal, it is actually 86. Okay, this is 86. So here the process is the opposite of what we did in the decimal to BCD code. So what we are doing here, first we have been given a BCD code. First what we have to do is that we have to make 4-bit groupings. Always start from the LSB side. Okay, always start from the least significant bit side and continue making 4-bit groupings until you exhaust all the bits available. Then write each of the 4-bit groupings separately. We just wrote here 1 0 0 0 separate and 0 1 1 0 separately. Then we converted each of the 4-bit binary numbers into their equivalent decimal form, and then we combined it together, 86. So it's actually the BCD code for 86, decimal 86. So let us take another example. Let us say we have another BCD code 0 0 1 1 0 1 0 1 0 0 0 1. Again the same step that we have to do, we have to make 4-bit groupings starting from the LSB. This is one 4-bit grouping, this is one 4-bit grouping, and this is one 4-bit grouping. Then we have to write each of the 4-bit groupings separately. 0 0 1 1 0 1 0 1 0 0 0 1. Okay, so this is the binary representation of 3. This is the binary representation for decimal number 5, and this is the binary representation for decimal number 1. So this BCD code in decimal form, okay, in decimal form represents 351 in decimal form. So here also the steps are the same. First, for the given BCD code, you start from the LSB side, you make 4-bit groupings, then you write those 4-bit groups separately, convert each of the 4-bit binary groupings into the equivalent decimal digits, and then you combine the decimal digits together. Okay, it's simple. Let us take another BCD code, and we have to convert it into the equivalent decimal form. Let us say we have been given 1 0 0 1 0 1 0 0 0 1 1 1 and 0 0 0 0. Okay. So here also the step is the same. We have to make 4-bit groupings. This is one group, this is one group, this is one group, and this is one group. Then we have to write each of the four groups separately. Total 4 4-bit groups are formed. So 1 0 0 1, this is one grouping, 0 1 0 0, this is one 4-bit code, 0 1 1 1, this is one 4-bit code, and 0 0 0 0, this is another 4-bit code. Now we have to convert each of the 4-bit codes, okay, 4-bit groupings into its equivalent decimal digit. 1001, it is in decimal form, it is 9. 0100, in decimal form it is 4. 0111, in decimal form it is 7, and 0000 in decimal form it is 0. So this BCD code in decimal form it is 9470 in decimal form. Okay. So this is how we convert any given BCD code into its equivalent decimal form. So all you have to do is the opposite of the BCD to decimal conversion. First, you see the BCD code which is given, start from the LSB side of the BCD code, make groups of 4 bits. Keep on making groups of 4 bits until you exhaust all the bits. Then write each of the groups, 4-bit groups separately, convert each of the 4-bit groupings into the equivalent decimal symbol or digit, then you combine the decimal symbols, you get the decimal number. Okay. So here we have discussed about the BCD, binary coded decimal system, or the 8421 coding system. We have discussed some the basic features associated with it, and how to convert any given decimal number into BCD and vice versa. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.